Hey guys, welcome back to the shop. This week I've got some lathe work. I've got a small lathe project that I want to share with you. I've got some odds and ends on the cutter grinder that I'll share also. And then of course I've got some odds and ends like always. So let's get started. So this cutter has turned out really well along the outside. It's not really finished, but just a practice piece that I'm just messing around with. You can see my primary cutting edge is in blue, it's dichomed, and then my secondary, which I've been grinding with this cup wheel. The secondary is 25 degrees and the primary is 7. And I've been grinding right now on the secondary, trying to narrow my primary down to about 1/16 of an inch. You know, there's a lot to grinding cutters, and I get asked pretty often, you know, hey, I've got a bunch of end mills, you know, will you grind them for me? You know, and unless you've got a whole bunch of the same ones, you know, where I can just do one setup, it's just not worth it. You could probably buy 4 standard, you know, 1/2-inch end mills for the price that it would cost for me to grind you one. Not because I'm high, but because it would take so long. You know, it's definitely a time-consuming job. You know, cutter grinders are great for the home shop guy who has plenty of time to do his own stuff. But or you know, if you're working on big wheel cutters for like a horizontal mill or something that are really expensive, now those make financial sense to grind. But one like this, you know, it doesn't make any sense to regrind this really, unless you want a custom end mill, and then it makes sense. But otherwise, it just takes so much time that you know, nobody's making money with a cutter grinder grinding readily available cheap end mills, because they're relatively cheap these days. But I think that's turned out really nice and been good practice. Here's the little stream that runs by my house, and then down here it empties out into the Elkhorn Creek. It's pretty down here. So I got a job here that I need to do, and some lathe work that was sent to me by a friend and viewer. A drawing and some material. This is stainless. So let me show you what we got. We'll go over the lathe and get started. Alright, so Jim supplied me with a really nice drawing. Jim is a viewer and fellow YouTube machinist. He's trying to get things lined out right now, so I'll tell you more about his channel in the future when he's ready. But he sent me this because his lathe is down, and he wanted me to make him these parts in order to help. So what these are, as far as I understand, are spacers that go under a large engine that you would use to power, really old, big engine that you would use to power a line shaft or anything really. And it's a pretty simple part really. 1 5/8" on the OD, inch height overall. We've got a 1/4 inch step here and an inch, I guess a standoff you could call this part, I'm not for sure. But tolerances are pretty lax on it. We've got 20 thousandths plus or minus on the OD of our step here, which is an inch. We've got 45-degree chamfers and a 0.64 inch bore through hole. So it's a basic part. Now normally what I use to do these chamfers, these 45s, is just a 90 degree tool. You come in, hit both sides. But I'm potentially going to need a tool in the future that is 45 all the way across for clearance reasons. So I'm going to go over to the cutter grinder. I'll show you some clips of me making it. We'll use it on this part, even though it will require a little more finagling to get our chamfers in. But I got a wheel and stuff that I want to try, and I like running the cutter grinder. So let's go over there. We'll do that real quick, then we'll meet at the lathe and we will make these parts for Jim. Alright, so extremely common Victor 1350 cutting torch head. I went to use this the other day, and oxygen was leaking straight through my cutting valve. We was going to cut some plate and ended up we couldn't do it. But I did rig this up to where it would work, and I made a new seat for it, but till I could get the actual parts to fix it properly. And all I did was put a piece of Teflon in it to make a seal. But I'm gonna replace this valve seat in this torch and get it back in good operating condition. Try to anyway. Gotta knock this pin out if I can. Knock that pin off. Handle pops right off. Here's the valve. It's just a roll pin. So actually, I made a little Teflon seat for this, just what I had, and it worked, and still works. I want to, get the right stuff in it. Screw this body off, and there's our plunger. Just seats on it. This torch is definitely dirty. And it just seats on a seat down there, and seals off the oxygen until you press the lever. So we're going to open up our new parts here and try to replace that. Spring, washer, O-ring. Gasket to the bottom of this. So basic really. Make sure that ain't even got a gasket in it. So set this down in there first. Seat that at the bottom. A lot of people have a torch, it won't be acting right, and they're hesitant to redo them, but they're real basic. Once you get into one, you're like, man, you know, if you've got one that's acting up, you should have fixed it long ago, because they're really, you know, just needle valves and stuff, pretty basic. Click. Put our pin back in, and literally that is it. This thing has a new valve and seat in it. I'll set this up on the vise and drive that the rest of the way through, but get the idea. That's how quick. There's a little Teflon seat I made just to get us by, and it worked. Check out our handiwork. See if it repaired it. See why it wouldn't. Looks like it should. Alright, so just a simple setup here. Got a 46i wheel. I just want to try it. It's a Radiac, very open structure, and a universal grinding vise. If you're going to get a cutter grinder, if you're even thinking about it, you really factor one of these into the cost. If you're going to be grinding high-speed steel or, you know, tooling for any of your machines, it's a must. So I've got compound angle in here. Got 45, and then 5 degrees, so 5 degrees below the cutting edge, and we're grinding our 45 in. So hopefully we can get this ground in without hitting our vise. If I have to, I may have to stick this tool out a little, but you get the idea. Nothing fast about a cutter grinder. You know, if you think you're going to get one and just grind cutters, you know, real quick, probably wrong. It takes a long time. It's kind of slow. Could have saved myself quite a bit of time by hitting the bench grinder first, but my bench grinder's put up at the moment. There's nothing rigid about this setup. That's why it's so noisy. Just a rough grind, but looks pretty good, I think. You know, you're not going to get these things hot enough to hurt them, grinding them like this. Alright. And it never really even got hot. coolant, I guess not too necessary on this, as long as your wheel doesn't load up. So let's take this out and let's look at it and see what we got. Right, so there it is. A little discoloration, but you know, this high-speed steel, that's nothing really. As long as you don't get it super hot, you're not gonna hurt it. And there's our angle. Now we just used the graduations on our universal grinding vise, and we're within a half a degree or less, or closer. So looks like we're 44 3/4, so you know, close enough. I mean, you know, this is not. We really need an optical comparator to properly measure angles like this, or a complicated setup. But for this, it doesn't matter. It's just for relief. So I'm going to leave this tool neutral. I'm not going to put any positive or negative rake in the top. We'll see how it cuts, and if I need to adjust it further, I will. But you know, finish is good enough for a lathe tool. I'm going to polish it up a little bit, and you know, we already have, you know, relief in it this way. So you can see that or not. But, so it has cutting edge relief. So I'm going to polish that up, and we'll try it. It's definitely easier to polish the edge when, or at least the top of the tool, when you don't have to, you know, deal with the rake angle. Then I'll get out my engraver, and I'm going to try to engrave, you know, to identify this tool. I bought one, a cheap one, and I want to try to use it, a new old stock, just handheld engraver. I wonder if it'll work on high-speed steel. So there's the engraver, just a cheap handheld deal. I'm gonna try it and see if it'll work on that high-speed steel. Should, I think. It's got a carbide tip. So I think I paid $5 for this, and I really don't think that it's ever been used, or at least if it has, it hasn't been much. So it's worth the investment, I think. If nothing else, you know, you can put your name on your tools if you'd like. I usually don't do that though. So I'll put 45 on this thing. Works. Not very deep, but I guess it has to be as long as it stays on there. Okay, so that worked pretty good. Went ahead and tagged it good. Alright, so I'm just getting into grinding, really. I'm not a person who does a lot of, you know, tool grinding, even though, you know, you see me do it quite often. I'm still just learning. But, you know, I ground the other side of this off camera. You know, they're just opposing. And I went far more aggressive on the second side than I did the first. And I was surprised to find that things went quite a bit better for me when I ground more aggressive. The wheel stayed cleaner, I guess because the wheel was breaking down faster and wasn't glazing up, and the tool stayed just as cool as it did before, and it cut my grinding time down by, you know, at least 1/3. So I was surprised to find that, and I figured I'd share that with you. You know, I'm still trying to be careful. You know, exploding grinding wheel could kill you, potentially hurt you bad anyway, and you know, I thought that was neat. I was surprised to find that. So I'm gonna have to really pay attention to the way that I grind, because it cut my time way down, and I still got, you know, just as good or better results. So I'm just getting all my tooling set up for this job. I really like to get everything set up first, especially when I'm making more than one. It's just quicker for me and less stressful if I have all my tools that I think that I'll need lined up and on center, and I don't have to mess with them as I go. So that what I just done on that cutter grinder really surprised me, to be honest. I'd always babied it, kind of babied it, in my opinion. Like I said, I'm not a grinder hand, but I'd always tried to go on the conservative side, and I definitely think that's the way you should start. But man, it grounds so much better. I couldn't believe how much better it done, just with a little more aggressive cut. So I'm going to get all this stuff set up, and we'll start making a part. So remember, our outside is our final OD, so we don't have to do anything with that. So we're going to come in. The plan is come in face, spot drill 5/8 bore, come in, do our 1/4 inch step down to 1 inch, and then go back partially part, then come in with our tool that we ground, and chamfer, and then completely part. So let's get started on this. We don't have a lot of extra stock, so we're going to have to be careful and not mess up. Face. I'm going to set my carriage stop. I got a micrometer carriage stop here, set it to 0. Now we can turn back to 1/4 inch. Alright, so I roughed with this carbide tool just to, hog material off, get me really close. Switch tools. Now I got a really sharp, pointed piece of high-speed steel here because we don't want a radius at the transition here because something's going to set on there and we don't want any interference. We're 9/1000ths off, or 1 inch, 9/1000ths here. Tolerance is within plus or minus 20, so we're good, but I'm going to get it a little closer with this. Come down in, touch my corner to make sure there's no radius there, and then feed out on the space, and then check my height here, and then face this if I need to get me within a 1/4 inch on my height. Then we'll spot drill, we will drill 5/8, then we'll bore, and then we'll come in and part and chamfer. It's almost impossible to get a good finish with a really sharp cornered piece of high-speed steel on this stuff. I hit 0 on my carriage stop down here. And now I can feed out. And we got enough material to where I want a good 90 degree transition here. Now I'll just check this height of this step and then machine that top off to get me to a 1/4 inch if I need it. 7/1000 large. Take off 5. All that good. So now we'll spot it and bore it. Spot it, and we will pilot drill it. Drill needs sharpened. Wait till that cools before we get a good measurement. Alright, so as far as I can remember, this will be my first time cutting a 4/16 stainless. You know, I usually work in the 316, 308, 310, 309, you know, 304, stuff like that. This stuff seems to break chips easy, but it's definitely harder to get a finish on than what I'm used to. So it seems to be a little terry. Let's just put it at that. More like mild steel almost, but it's a stainless. It's kind of strange. Size check. It cuts a lot like mild steel, I'll have to say. So yeah, within a half thou there. Pretty good. On the board, other than I may run a piece of cloth up in there. Let's get that edge off. Stuff does cut well, but it is a little tough. Looks alright though, so far. Alright, so now it's time to do our 45s on our chamfers. So we'll hit these two surfaces here, then we'll have to flip the tool to do the other side. Zero. I want to get them all the same. pretty good. Touch. 0. There we go. There's both our chamfers. Alright, so I'm about ready to part this thing off, and to get set up, I just first made sure that my tool post and holder are square with my chuck and the work, and that my tool that I have in my holder is also square with the world. Took this far edge here and touched off against this shoulder. I know I want 3/4 of an inch between this shoulder here and my parting point. So I know how wide this tool is, so I touched off. I zeroed my travel indicator, or my carriage stop, and now all I got to do is move back the amount that I want to cut this back and add the width of my tool, and that'll give me an accurate part. At least that's usually the way I do it, and it always usually works out. Always usually. So let's cut this thing off. All right, so there's 0. So move 3/4 of an inch. Okay, so that's got me right there. It's got me my far edge where I referenced on my line. Hopefully you can see that. And now I just need to move, this way, the width of the tool, and then that'll put my far edge on there, which is 157 thousandths. That should be it right there. There we go. There we go. It's a pretty good looking part. Even though we had to go back in with the parting tool, it didn't hurt anything. It broke free. Alright, so there's our part. Looks pretty good. Even chamfers all the way around. Pretty decent finish. We'll measure it in just a second and see how close we got. Get this layout fluid off of it. Some of this CRC layout fluid remover. Shouldn't get that on your hands. So, looks pretty good. Nice looking part. It's exactly, basically, it's exactly almost what our drawing is. Let's measure it and see what kind of numbers we hit on it. Alright, so overall length, we wanted 1 inch. We've got 1 inch, 1.5 to 2 thou. That's good. Our OD on our step here is 1 inch. we're basically on the money, 1 inch. Our bore is 0.641. And these aren't the most accurate way to measure something, but you get the idea. So we're within we're within a thou or two, which is pretty good. Let's see, our step, we wanted 75. So we're a little large on our step, within 3.5 thou. And you could always go back in and dress that back up if you want to. I still got to deburr this back edge. And let's see what else. So that's it, really. We wanted no radius in the corner, and we used a sharp high-speed steel to do that, and we got an acceptable finish on it. So I got to make 3 more exactly like this, and I'll come back and get them all exactly the same, at least within a thou or so. But we're well within the tolerances that this drawing required, and got a good part. Didn't take very long. So now that I'm set up with all my tools, I can knock this out without a camera, in just a couple of minutes. So probably 10 minutes, I'm guessing. So nice little part. Well, this little project is complete. Got all 4 of them done. I took a piece of drop, the piece that was left from this project, and I stuck it over in the small lathe because I wanted to see if it made much difference if I spun it faster. And man, it made the surface finish just double with a faster spindle speed. So, that's one downfall to some of these old lathes, is that they're just not fast enough for some of these materials to get a really good finish on. But they turned out really nice. I mean, I'm happy with them, and they're within a few thou each. I checked them, plenty accurate enough for what they are. So these are about to go home now. I did come out here one day this week, one afternoon that I had an hour, and ground this parallel on the surface grinder, the grinder that I've been showing, and I'm surprised to find that in the middle of the chuck it does really well. The only place that it seems to have real accuracy issues is out towards the end. So the vast majority of stuff that I would have done anyway with the surface grinder, I can still do with that, even though it has some inaccuracies, in the ends of the ways. Making parallels and stuff, that's what I wanted to do anyway, and I can still do it on that machine, but it definitely needs some work. So I plan to fix it as long as I can get it done at a reasonable price, because that machine's just not worth sinking a lot of money into. But I am so glad that I got it. It definitely opens up some doors for me that I couldn't do on the cutter grinder. They're not surface grinders, and there's a big difference between the two. The rigidity of the machine's the major difference. So I was happy to find that I could get this within 1/10 or so over 6 inches, which is plenty good enough. So I think that's it. I've had a couple people get upset with me over the last couple weeks. They'll send you an email or something, and you either forget to respond, or just say, oh, okay, I'll get that tomorrow, and then you forget. Well, I get anywhere from 50 to 100 emails a week, easy, including my work, and some stuff just gets forgotten. So if you get upset easy or get your feelings hurt, you probably shouldn't be emailing a YouTube guy. We're all the same. Busy. That's all I can say. It's not that we don't want to respond or anything. I've always tried to. I mean, all my long-time viewers know that. I do try, but I'm not always successful, and I just want to apologize to anybody who got their feelings hurt. Not intentional by any means. So big thanks to all the guys who made a donation on my link in the description of my video. I really appreciate that, and it justifies me spending all the time that I do, every week trying to give you something to watch. And I enjoy it. I really love the comment section and stuff. So thank you guys. Big thanks to my patrons, viewers, subscribers, and I think that's it. So thanks for watching, guys, and I'll see you next time.